Hello again, Year 8. Another revision video for you. Short but sweet this one. This one's just going to be about heat transfer. So when we're talking about the transfer of heat, there are three ways that heat can be transferred that you need to consider and be able to describe in Year 8. So those three ways are described in your booklet. Let me find the page. And we'll turn to that in just a moment. You need to describe exactly what's happening during conduction and give two everyday examples of conduction and describe some good conductors and some insulators. So materials that are very good conductors and materials that are insulators. You need to also be able to assess how good something is at insulating heat energy, and we'll talk about that on another video later. Let's just move to conduction. So we are on, and I don't know if I'm going to get the right page here because I don't have the paper booklet, just got the electronic booklet. So bear with me if your page numbers are slightly different. So here, I think this was page 31 in the paper booklet. The first type, and arguably the most important type of heat transfer that you need to know about, is conduction. Now, what we did in class is we described conduction as heat transfer by direct particle-to-particle contact. So the particles literally bump into each other and transfer that heat energy. Okay, we're measuring heat energy, remember, in joules because it is energy. But remember that what temperature is it's the average amount of energy in a substance. And that's measured in degrees Celsius usually, although there is also degrees Fahrenheit and degrees Kelvin. But for today's purposes, we're going to talk about energy and heat energy measured in joules. So a substance that has its particles very close together, tightly packed, is actually able to transfer the heat directly from one to another. So what you can see in your diagram in your booklet is the heat energy being applied to these particles here, and assume that this is something like a metal. And that increases the movement in the particles, and that movement allows the heat energy to be transferred to all of the surrounding particles. So if heat energy is applied to these two, that will transfer the heat to all of the surrounding particles, which will then in turn transfer the heat onwards. So conduction relies on the particles within the material being very close together and tightly packed. What that means is that good conductors of heat energy are solids and poor conductors are liquids and gases. What it also means is that the harder the solid, or the more dense or tightly packed that solid, the better the conduction. So when we describe examples of conduction in our everyday life, typical things that we need to conduct heat are things that we might use in the kitchen. So you need a saucepan or a frying pan to conduct the heat from the flame up into the food that you're trying to heat. If the frying pan was an insulator, it would actually slow the transfer of heat from the flame, the gas flame or the electrical stove, to your food, and that wouldn't be very efficient at all. So when you're thinking of examples of conduction, think of things that when you apply heat up very quickly and transfer that heat very effectively. So something such as a metal teaspoon sitting in a cup of tea will heat up very quickly, and you can actually detect that increased heat energy in the spoon as it sits in there, because it's moving from particle to particle, and even though the handle of the spoon isn't actually sitting in the tea, it does heat up because all the particles are in very close contact with each other. So that's probably the most important type of heat energy transfer that you need to be able to describe, and it depends on the close proximity and direct contact between the particles. So read through your booklet and ensure that you have conduction of heat energy in your Quizlet. Now remember that the opposite to a good heat energy conductor is an insulator. And insulators are things that don't conduct heat energy very effectively. Air is a very good insulator, which is why things like maybe an esky, which is designed to keep heat out from cold foods, actually has plastic walls but with a big air pocket in between. And that actually prevents rapid heat loss or heat gain to whatever you're trying to insulate. Other things that are very good insulators, double glazing is a good insulator because again it traps air, and air being a gas is a very poor conductor of heat energy, so it actually insulates very well. It prevents the movement of heat energy through by conduction. The other two examples of heat transfer that you need to be able to describe are convection and radiation. Now, convection is based on the particles and how the particles are behaving. So when you add heat energy, as seen in this diagram down here, two particles, we know that solid particles are close together. You add energy and you can turn it into a liquid and the particles are further apart. You add more energy and the particles are even further apart and it turns into a gas. Okay, so what we're doing as we move particles in a substance further apart, we give them more energy, then the density per unit of volume is less. So how much space between those particles is increased. And that means that those particles are lighter and they will float. So whether you are heating up air, which is obviously full of particles, or a liquid, the warm air that has more heat energy will rise and the cooler air will sink. And that creates convection. And we can describe this in terms of convection currents, which is the movement of air or liquid in a circular motion up as the heat energy is added and makes the particles less dense, and then down, back down again as the particles move closer together as the heat energy is lost. Okay. The final one is radiation. And the main thing that you need to know about radiation is that radiation is the type of heat energy transfer that can occur through a vacuum. So we can get energy from the sun, but it's not based on the particles between us and the sun directly contacting each other, which is necessary for conduction. So it's not transferred by conduction. It's not circulating based on the density of the particles, which is convection, but it's actually moving as a wave. It doesn't rely on particles at all, which is one of the key things to remember about radiation, and it can travel through a vacuum. Okay, so we get most of our energy from the sun on Earth. Oopsie. And that travels from the sun to the Earth through a semi-vacuum with very, very low density of particles, and that's by radiation. And that's all you need to know about that one. Going to your conduction page, make sure that you can give, so this is page 32, describe conduction in your own words, give some examples of conduction from your own life, and describe a situation or an example of a good insulator. So a good insulator is just a poor conductor of heat energy. Well done.